know where our Z point is. Okay, our Z point is exactly over here. So this is our Z, right? And then our shear is at 9,000. So we have our shear at 9,000. At the top. And then the shear, we also have to draw the 9,000 at the bottom. Right? And then based on that element rotation, if we are going to do point X first, right? This shear will rotate the element in a anti-clockwise direction. So point X will be down here. Right? And then up here will be our point Y. So this is our point Y. Okay. Then now we can construct our 3D Mohs circle now. Okay. So we're going to construct the main circle. Okay. So this is our. Okay. So what we want to identify is we want to identify where is our point O now. Okay. That I call our point O. Okay. Or that is also, if we were to draw, this is also equal to our stress average. Okay, so from here to here, so we have to identify what is our stress average. So the center of the circle now. Okay, so this is the center of the circle. So what we're going to identify first is what is our stress average. Okay, so this is the stress average that we want to find. Okay, so this is our stress average. Okay, so stress average, or I'm going to construct the circle first. So if you have a compass, you can start constructing your Mohs circle. Okay, so we can construct our Mohs circle first. So this is the Mohs circle. Okay, I'm just sketching this. Okay, unfortunately the computer does not have a compass. Okay, so I have to sketch this out by guessing, and it's good enough. Right, so this is our first Mohs circle, as you can see here. So now what we can do now, right? We can find our stress average, center of the circle. Okay, so we can directly from here, we can calculate our center of the circle. Which corresponds to the position that we've drawn, which is equal to the stress average. So this will become minus 15,000 plus by 2,000 divided by 2. Okay, so it's at minus 6,500 psi. Okay, so based on our construction, yeah, I might be a bit off. Okay, as I say, this is just a sketch. No, we are spot on. Okay, so why do we need to draw this first? Okay, so we know this is going to be 3D, yes or no, right? The most important thing, the first thing we have to do, we have to identify what is our stress A, where's our stress A, and where's our stress B. And for this, we have to now construct 3D Mohs circle. So now we know the first circle that we have drawn, this belongs to the what? This belongs to the XY plane. Okay. And then we can construct another set of circle, right? So because our Z point is over here, right? Our Z point is over here, we can construct the other two circles. So I'm going to sketch the other two circles first, okay? So 3, 6, 3. So I'm going to use a different color now. All right, so this is one circle. And this circle over here belongs to the what? Exact plane. And then the other circle over there. So I'm sketching the other circle. Okay, so this is our the other circle. And now this one belongs to the YZ plane. Right? So this is a complete 3D Mohs circle now, okay? Because we are looking at real life structure. They are 3D, okay? As I mentioned before, they are very seldom in a 2D configuration, right? So from here, we can state that this is definitely our what? This is definitely our stress A, or this is our stress B. Anyway, okay? And this will be our stress A. So now we know that our stress A and stress B are in plane. Okay. Right. So from here, we find our stress A and stress B value. Okay. So the next, we're going to identify what is the radius of the circle. So this is correspond to our tau max. So this will be equal to the shear. That is 9,000 squared. Right. So the 9,000. So we want to find now. We want to find the radius now. Okay. Now we want to find the radius. So we know that this value over from here to here, right, from here to here, this is equal to 9,000, right? So we want to find, what we want to identify is the radius from here to here now, right? We want to know what is this radius over here. And then now we need to find this position. Okay, we need to find this distance now. Okay, so we need to find what is the distance from here to here. So the distance from there to there is 6,500. Right, so it's equal to 6,500 or minus 15,000 minus by 6,500, right? And then this will be equal to, where is my calculator? So minus 15,000 plus by 6,500, so it's equal to minus 8,500, right? So this is distance. So this will be equal to plus by minus 8,500 squared. So this will be equal to 9,000 squared. Hold on, there's something wrong with my calculator. Hold on. Okay, so 9,000 squared plus by 8,500 squared. Square root of the whole thing is equal to 12,000, 12.379.4 psi. Okay, so from here we can immediately identify our stress A and stress B. Okay, so stress A B is equal to minus 6,500 plus or minus 12,379.4. Okay, so from here I will have stress A is equal to, so minus 6,500 plus by 12,379 minus 6,500 plus by 1,379.4 is equal to 5,5879.4. and then stress B is equal to minus 18 point or 818,879.4 psi. Okay, so we got this sorted out already. Okay, so the next thing we are going to do, we're going to find if is this greater than 1 or less than 1. Okay, so it's just matter of substitution. So I'll try to squeeze everything in here. Okay, so I can see the number also. So we're going to have stress A. So we're going to apply stress A divided by stress ultimate tensile minus by stress B over stress ultimate compression. Okay, so this will be equal. So stress A will be equal to 5879.4 divided by our tensile, which is 10 times 10 to the power 3, minus, and you have to include the sign, minus 18,18879.4, right? And then the whole thing divided by 30 times 10 to the power 3, right? So the compression down here, you don't need to include the minus sign. So this will be equal to 58.9.4 divided by 10 power 3, 0.588, minus will become a plus, is 0.6293, right? So this will be equal to 0.588 plus 0.6293 is equal to 1.2173. So you realize that this is greater than 1, so therefore, right, it's greater than 1, so therefore what will happen is the structure. Hold on, let me get rid of this. I need more space. So therefore structure not fail, sorry, will yield. Okay, so this is Mohs criteria. So it's very easy. Okay, if you ask me which criteria is a bit lengthy, I will say von Mises. Okay, Tresca is so easy because Tresca is just take the U divided by 2, you got the maximum shear. And again, if you look at Mohs criteria, it's also very straightforward, right? Is just knowing that you have to consider ultimate tensile, ultimate compression. Okay, so the structure will yield. So again, regardless of whatever criteria you have to use, that you are going to use, you have to still construct 3D Mohs circle. The purpose of constructing 3D Mohs circle to make sure that this is stress A, and this is over here is stress A and stress B. If your circle is shifted to the left, okay, what if now this stress is also compression? Okay, you don't know, because there is a possibility that at point Z over here can be one of your principal stress value. Okay, if your circle go to the left hand side. So what do I mean by that? So I will sketch down here. What do I mean by that? Okay, so over here, this is our point Z. Okay, so let's say this is your this over here, right? This is your XY plane. Over here is your XY plane. Then you have another circle down here, right? It's different now, right? And then you will have a bigger circle over here. So there's a possibility this is going to be your stress A, and this is going to be your stress B. Okay. For this case, that is not the case, right? Because we look at stress Z, right? If we look at stress Z over here, or point Z, right? Okay, point Z over here is within the circle already. Okay, whereas the other one that I've just sketched up, the XY, okay, the XY is this circle over here. The XY plane is this circle that I'm going to highlight. Okay, I'm going to highlight now. And then stress Z over here is going to play a part in analyzing your Mohs criteria. Okay, so you have to be really careful, right? Okay, so this is the end of the series of 2D, 3D, And then we have been looking